In this video, I discuss my idea on how to decouple the object's actual logic from the state machine system, making it reusable. Before that, let's see what a state machine is. A state machine consists of some state manager as the parent of some state classes. The state manager has a reference to the currently active state, running its process, physics process, etc. in the runtime. It also has a function to change the reference to the active state in case it changes. The child states contain the actual functionality of the object. So for example, the idle state may run some idle animation on loop, and the walk state moves the player if the appropriate input is pressed. States need to make transitions to each other. That's why they have a reference to the state manager and call its change state function when necessary. In this case, the idle state would make state manager switch to walk state if the appropriate input is pressed, changing the currently active state to walk. The walk state takes over, controlling the movement. When you search for state machine tutorials, you see everybody is putting the actual walking logic right inside the walk state, and this does work, but it forces you to recreate the state classes again and again for each new object in your game. Wouldn't it be cool if you could decouple the object logic from the state, making it as generic as possible, maintaining reusability? Based on the concept of the previous video in the series, this can easily be done. And actually, I had implemented the system in Unity long before. It was a pain in the ass because C# actions can't be serialized to be shown in the inspector, and Unity events have the reputation of being slow. But Godot support for signals and the observer pattern makes my idea much easier to implement in this unique game engine. Let's have a look at the theory behind the system. Following my advice in the last video, we first need to separate the functional aspects and the conditional aspects of the object's behavior into reusable modules. The functional ones listen to signals to perform their function. The conditional ones check for specific conditions and emit signals if those conditions are met. The brain would be a state manager plus a container of all the valid signals of the object. Every child module is allowed to use only the signals registered in the brain, and states are no different. They would listen to valid signals and emit valid signals in return. The point is that this is all they do. There would be absolutely zero functionality in them. They are just like signal hubs. And this is exactly how a living organism works in real nature. A real brain does not move. It just orders the legs to do what they are supposed to do. The leg muscles are listening to the signals coming from the brain. They have no clue about the state of the living organism. It doesn't matter if the movement is initiated for hunting or for running away from danger. That's why in my implementation of the brain system, states must only be signal hubs. Back to the example provided in the previous video. The input manager would emit appropriate signals if the input condition is met, and the idle state would listen to those signals and make the brain switch to walk state. The walk state listens to the same signals and emits movement signals in return. The mover module is listening to the movement signals, and when the walk state or any other state emits them, it will move the object. This way, the state manager is completely decoupled from the functional and conditional aspects of the behavior, maintaining reusability to its fullest. Now you may wonder if this is gonna make the workflow more efficient, or it's just a new layer of complexity devised by some masochist maniac having an obsession for perfectionism in maintaining OOP principle. Well, if you implement such a system purely in code, it will be a new layer of complexity, and you would still need to create a new brain class every time you make a new object. The system's potential is unleashed if and only if some clever editor scripting is added to the mix, enabling the designer to implement the signal hubs and the valid signal list right inside the inspector of a generic brain node containing generic state nodes as its children. And this is exactly what I'm working on right now. I have some technical difficulties in the editor scripting aspect for the moment due to lack of comprehensive guides on how one is supposed to do some fancy stuff inside the inspector. However, when implemented successfully, one would need absolutely 0 lines of code to make the brain system work with its newly created objects. Subscribe and hit the bell so you don't miss my devlog on the creation of that beast. Thank you.